Now we are going to deal with the most interesting thing. Tell me what? We are going to deal with the image formed, the characteristic and nature of image formed in different types of mirrors. So how many mirrors do we have? Okay, two types. One is plane and another is spherical. Okay, how many types of spherical mirrors we have? Okay, two types again, concave mirror and convex mirror. First of all, we are going to see what is the image formation. It was in class 8th in a plane mirror. So if we draw any image formation in a plane mirror, see, it's very easy. Like if you put a candle over here, you need not have to draw it in exam, but still I am telling you. Sorry, the flame is a little bit bad. Okay, now suppose this is a candle. Simply you have to find the distance, and this is, make it straight lines, and this is what reflection is. There lies the top of the candle. This is what the solid line, and this is what, there lies the bottom of the candle. Okay, the candle is becoming more fatter. Okay, this is the top and bottom of the candle. Now close the candle, and also we are going to take up another one. We are going to make a flame of the candle. Okay, so this is what a mirror image of a candle. If you write K, then similarly you can write like this. So we did it already. So if you're going to write N, then we are going to write N like this. So they are asymmetrical, right? We have line of symmetry. If you have a line of symmetry like O, then we are going to O as a mirror image. So simple. Lateral inversion takes place, what I was trying to explain. Let us understand them with a technique. Like, I have a friend in America whose name is Velis. Whose name is Velis. So Velis spells like VELI and SS. So you are going to learn the nature and characteristic of the image formed in case of a plane mirror with Velis, with that friend of mine. VE stands for virtual image, and as it is virtual, it is erect. The relation between virtual and erect is quite, we are going to study it. We are going to see it, how virtual means always erect and how real means always inverted. We are going to look into it later on. V stands for virtual, E stands for erect, LI stands for laterally inverted, the one I tried to explain you here, laterally inverted. Then SS stands for same size. Okay, this is what the image formation in case of a plane mirror. Give a bullet, write the image is virtual and erect. Give a bullet and write laterally inverted, the image is formed which will be laterally inverted. Give another bullet, write same size. If you ask for another one, the object distance will be equal to the image distance. This is the last one. Okay, these are the four characteristic, 1, 2, 3 and 4 characteristic of image formed by a plane mirror. Though this question holds some importance, you should remember the points because it may come and it will be very terrifying, it will be very bad if you leave this one and come. By a plane mirror. So these are the four characteristics we have discussed, image formed by a plane mirror. Next we are going to study image formed by spherical mirrors. I will tell you that on the basis of object position. Did you get virtual and erect, laterally inverted, same size and object distance is equal to image. These are the four. Please do it, please remember it. Make this, you can make this diagram, don't worry, just write down image formed by a plane mirror and write the 4 points. Done. After successfully beating the image, the characteristic of image formed by a plane mirror, we came to spherical mirror. Out of the spherical mirror, we are also going to discuss about concave mirror now. So what is a concave mirror? The reflecting surface is caved like this, right? So we have a concave mirror of which we have 6 ray diagrams. So you will ask me on what basis these ray diagrams are developed. They are developed on the basis of, guess, any guesses? Basis of object position. So you would naturally ask, do there exist 6 object positions? Yes, there exist 6 object positions, and these the remembering of this object position will also help you do the 6 diagrams of lenses also, the convex lens. Okay, now let us understand the general diagram. What are the 6 object positions that are present with us? Okay, before to that I will tell you some terminology. Like this line which crosses the concave mirror nearly in half, nearly in the midpoint, this line is called as the principal axis. Please write it down. Principal axis is the line which passes through the center of the concave mirror. This point where it meets is called as pole, right? As I have already told you, this is a part of a complete sphere, right? Like there is a sphere which must be there, and which would be the parent sphere of this concave mirror, and the center of this sphere is told as center of curvature. Center of curvature. Okay, and this length is called as radius of curvature. Radius of curvature. Now this, let us take it as R. Clear? Now of which circle, of which sphere this concave mirror is a part of, that center of the sphere will be called as center of curvature, and the distance between pole and center of curvature, that is called as radius of curvature. This can be also denoted as C. Many of the books, they have also written 2f. Why 2f? Because half of its length is termed as focus and it is denoted as f. So naturally, if this is focal length, let us name it as focal length. You are also going to deal with focal length numerically over the mirror formula, in which you are going to get the object position, image position and focal length, the relation between all of the three. Center of curvature, this is C, and this is R, radius of curvature. This is 2f. This is so many of the books they write 2f, and this is focus. This is the basic terminology, and we are going to also discuss the definitions of this, but later on when we are going to discuss the question patterns, then we are going to discuss them. And this is what the entire diagram, general diagram. Let us learn about 6 image position. So let me write 1, 2, 3, 4, 5 and 6. These are the 6 image position, object positions I told you. When you remember this object position, you will feel very happy that the lens also have these object positions, and the diagrams in the lens also you are going to deal with this object position. At first, the object is indicated with a ray diagram. Okay, the object is indicated with a ray diagram. The first object position is I am going to take at infinity. Infinity means there is no distance, there it cannot be seen. So naturally there is no object present, but there are rays present which come near parallelly. And the object position, the first we are going to deal with at infinity. The object is at infinity. Then when it comes to the center of curvature, when it is present, and it is present behind the center of curvature, we are going to tell it object beyond C. C, you can write it 2f, no problem, because many of the books they have also written it twice of the focal length. When the object is present behind the center of curvature, then if the object is again shifted, it is being shifted from infinity towards the pole, and these are the different positions. We are going to get 6 positions in between them. When the object is positioned on the center of curvature, we are going to tell it is the object is present at C, right? So again this is shifted, and again let the object be present in between center of curvature and focus. We are going to tell it at the 4th position, and we are going to tell it in between C and F. In between F and 2F also you can write, no need to have confusion, I will write it at C further. Now again it is shifted, and the position now came to focus. So the 5th position we are going to write at F. Again, if that goes on further, The object will stand in between focus and pole. We are going to write it. The sixth position in between F and P. The pole can be also denoted as P. These are the 6 object positions, and we are going to find the image of this position. Even the questions are asked, numericals are asked on any particular one. Like the question will be given and it will ask draw the ray diagram of the image formation. So you choose, by using your mind, you choose from which of these the situation has been illustrated, so that you can find out and do the exact one. Okay, now let us see how this image is formed at these 6 places one by one.